Good morning, students. So today we can start a new topic, that is GPS survey. So in the previous lectures you have studied what is GPS, that is global positioning system. It's a new technology in order to find out the location of an object, and we have discussed what are the different components of GPS and what is the principle behind GPS and how we are calculating the position, etc. And GPS survey, it's a new technique, and GPS has become a standard surveying technique in most surveying practices. That is, you have studied so many surveying methods like chain surveying, theodolite surveying, then compass survey, then plane table surveying, etc. Okay, so in all these surveying technique we need a lot of equipments. Okay, and also we have to go through so many complicated steps in order to find out the final result. But in the case of GPS survey, if we are doing survey work using GPS, the equipment we are using, that is the GPS equipment, is very small. Also, we can locate the position of any point within a short time period. Okay, so this could be this is very easy to use, and also reduction in hardware cost comparing to our previous surveying method. And also you have studied total station. Okay, total station actually total station is the start of this new technology, and in total station you can download the output. Okay, so like in total station works under the principle of EDM. Okay, electronic distance measurement. And in GPS also, if we are calculating the location of any point, we can also download the data. Okay, so here we are using software technology. So this is most advanced technology, and it is very easy to use, and also reduction in hardware cost. And GPS eliminates the need for establishing control before a survey. So if we are doing a GPS survey, there is no need for establishing control. So it's very simple technique, and there are a lot of advantages of GPS survey. That is it is three-dimensional. We can obtain the three-dimensional data of any object since we are using 24 satellites. Okay, and sight indivisibility is not needed because the object is viewed from far distance, that is from satellite. So sight indivisibility is not needed, and it is weather independent, and it can be operated during day or night, and there is a common reference system and rapid data processing with quality control. We'll be getting high precise data, and that is, the precision is very high, and less labor intensive and cost effective technique, and very few skilled persons are needed in this technology. Okay, so this is one of the most advancing technique in survey. So next we can start about GPS surveying methods. Okay, so mainly the GPS surveying method is classified into two types. First one, absolute positioning. Second one, relative positioning. Okay, in the case of absolute positioning, there will be only one receiver, and it may be either stationary or in movement. For example, this is absolute positioning, that is, here there is only one receiver, that is the point whose position is to be found out is located here, and we are placing the GPS equipment over the point whose position is to be calculated. So in this technology, in absolute positioning, there is only one receiver, and this receiver may be stationary or moving. Okay, if it is stationary, it is static, and if it is moving, it is known as kinematic. That's another classification we will discuss later. So in absolute positioning, there will be only one receiver, and it is applied for determining the absolute position of a station. So we are calculating the location of this object using this receiver, which is located above that object. Okay, and single receiver in static condition, if it is single receiver in static condition, it is known as absolute static method, and single receiver in kinematic condition means single kinematic method. And these methods require long duration of observation. So we have to locate the GPS equipment for a long time period in order to locate or in order to find out the location characteristics of that point. Okay, so the location of this point is calculated or determined using a minimum of 4 satellites. Okay, using 4 satellites we can locate the position of the object. So in absolute positioning there will be only one receiver, and this absolute positioning may be static or kinematic. That is, if it is moving, it is known as kinematic, and if it is stationary, it is known as static. So that is about absolute positioning. Okay, next is relative positioning. So this is the figure showing relative positioning. That is, position of receiver at unknown point is determined with respect to a receiver at known point. That is, here there will be two receiver. One will be located at the known point, and the second one is located at the unknown point. Okay, so here this is the receiver which is located at the known point. That is, the position of this point is known, and this is known as reference point. So one GPS receiver is located at this known point. Okay, and the second receiver is placed at the point whose location is to be found out. Okay, and that is also known as rover. We can discuss it later in detail. So I am just explaining the classification. So in relative positioning there will be two receiver. One is located at a known point, and the another GPS receiver is located at the unknown point. Okay, so this is known as relative positioning, because we are finding out, or we are finding the location of this unknown point relative to the location of known point. So it is known as relative positioning. Okay, that is, I had told that the location details of this point is known and this is unknown. Okay, and using the location details of this point, we are locating, or we are calculating the location parameters, or latitude, longitude and altitude of this point. So it is relative to this known point, so it is known as relative positioning. Okay, so this is one of the classification of a surveying method, that is absolute positioning and relative positioning. In absolute positioning there will be only one receiver, and in relative positioning there will be two receiver. So we are calculating the location of the unknown point with by relating the position of known point. So it is known as relative positioning. Next classification based on movement of receiver, that is static positioning and kinematic positioning. That is, in the case of static positioning, the object whose location is to be found out is stationary. So it is known as static positioning, it will not be moving. And in kinematic positioning, the object will be moving. Okay, so this is the second classification. So this static position may be in absolute or in relative mode. That is, static position in absolute means there will be only one GPS receiver and is static. And relative mode will be, there will be, in relative case there will be two receiver and will be in static condition, that is they are in stationary. Okay, like that in kinematic position also it may be absolute or relative. Absolute means there will be only one receiver, and in relative mode there will be two receiver. And in since it is kinematic, here it will be moving, the point will be moving. So this is the classification of GPS surveying method. Next, based on this, we can discuss different surveying method. So under static survey, static means the object whose location is to be found out will be stationary. So under static survey there is traditional static method, rapid static method and pseudo static method. And under kinematic or dynamic survey there is stop and go, traditional kinematic, kinematic on the fly and real time GDPS. So we can discuss one by one. So first, static mode of GPS surveying. So this static mode of GPS surveying is the first and primary technique. Okay, here it will be stationary condition. So a relative positioning technique which employs two stationary receivers simultaneously tracking the same satellite. That is, there will be two receivers, and these two receivers will be stationary, and these two receivers simultaneously track the same satellites. That is, there will be a minimum of 4 satellites, and these two receivers will be simultaneously receiving or tracking the same satellites. Okay, and one receiver is placed on point whose coordinates are known. Okay, that is this figure, that is one receiver is placed on the point whose coordinates are known. So that is known as reference receiver. And the second one is placed over the point whose coordinates are unknown here. Okay, and that is known as rover. Okay, so there is reference receiver and rover. Reference receiver means its pointer or its coordinates are known, and in the case of rover its coordinates are unknown. and based on collecting simultaneous measurements at both the base and remote receivers for certain period of time. So for a certain time period we are collecting the details from these satellites, and after processing yield the coordinates of unknown point. After processing for some time it will give the coordinates of this unknown point. Okay, and this type of survey is primarily used to create control where no control exists to very high accuracies. That is, here we are using this surveying techniques we are using by to create control. That is, here we can locate the unknown point relative to this known point. So there is a control over the surveying technique. Okay, and each receiver at each point records data continuously for a pre-planned length of time. Okay, for a pre-planned length of time these receivers will be collecting the details from the receiver, and the duration of data collection depends upon the required precision, number of visible satellites, then satellite geometry, and whether the receivers are single frequency or dual frequency, and distance between the receivers. So based on these parameters the duration of data collection varies. Okay, and this involves long observation time. That is, in static method the observation time is very high, like 1 to 2 hours, depending upon the number of visible satellite. If the visible satellite is less, the duration also increases. Usually it varies from 1 to 2 hours in order to resolve the integral ambiguities between the satellite and the receiver. That is, in order to receive the data from the satellite to the receiver, the duration of time is very high, that is 1 to 2 hours. Larger the constellation of satellite, lower the session duration. That is, if the constellation larger the constellations of satellites, the duration will be less. Okay. However, a higher accuracy for the baseline components can be achieved by collecting data for longer period of time. That is, if you are collecting the data for longer period of time, the accuracy will also be very high. Then post-processing software analyze all the data from the receiver simultaneously and obtain the differential position between the two receivers. That is, software analysis will be done, post-processing software analysis, and we will get the position from the receivers, and it will offer high accuracy of 1 centimeter to 0.1 centimeter over long distance like 10 kilometer. That is, if the distance between the two receiver is 10 kilometer, we can get high accuracy like 1 centimeter to 0.1 centimeter. Okay, and there are some requirements for this static method. That means there will be more than one receiver. That is one requirement, more than one receiver should be there. Then chance of getting direct signal from 4 or more satellite. That is, there should be signals from minimum 4 satellites, and should be unobstructed sky above the station to be occupied. Unobstructed sky above the station to be occupied, that is another requirement. And there should be enough power supply to complete the observations, and enough memory space to store all the data for post processing. So these are the basic requirements for a static method. Next, application of static method, and this static method is usually used for geodetic control over larger areas. That is, in order to have the geodetic data over larger area, we are using this static method. And also, since this is very accurate, we can use this technology in order to monitor tectonic movements. Okay, so in order to monitor the tectonic movements also we can use this one, because the precision or accuracy is very high in this method. Okay, and it is used for network adjustment to obtain highest accuracy. In order to find the survey network or network adjustments, we are using static method. So these are the application of static method of survey. So this is known as this is the first method, that is traditional static or static method. So next is rapid static, that I will put in the next video.